Hey, good evening. Um, I didn't record anything today, because I've literally been just music on trying to get this done for the presentation tomorrow for computer architecture. So I'll just kind of give you a run through of where I'm at right now and then get back back to work kind of. Um, and I don't want to worry about like I don't know. I just didn't want to record what I'm working on. Um, so but anyways, nothing really to update apart from what I'm working on right now. Um, so yeah, I guess I'll just run you through what is happening. Um, so hopefully if I close this and then reopen it, you can like see it again. Um, but basically, um, so if I just give like an overview, so the simulator is like, what starts everything. And it gets started by our API. So the API is doing a sub process of the compilation of simulator, right? So I do a make on this and everything else, right? And it's stored into simulator.exe. And then I kind of run that as an instance of a sub process right here. And so what I do is in interface, which is the UI that I just closed. Um, if we go here, obviously we're connected to the Flask API. And if we come down to, so load instructions, calls load instructions, which basically you just upload a file. And then down here, you upload the file, we start a new thread. For some reason, because I'm already running a sub process, if I also try to start running a function, it like the UI like freezes. So I have to do this on a new thread. And so then if we go down to handle instruction result, um, we um, actually, is there a different function before this that I'm forgetting? Not execution. Um, no, I think that might just be it. Um, but basically, what it does is we get in the result of loading that file, and then we just update the code instructions and initialize all the memory fields, and I think also not the register fields, but all the memory fields within the UI. Then, um, also in the interface, after I do that, so I don't have the next thing I have to do is this step one cycle thing, because I have in the UI. I mean, if I just launch it right now, and does that show up on recording? Yeah, it does. Nice. Um, if we look at the UI, there's a pipeline, and so I need to show what's happening at each stage of the pipeline um, for the demo. Um, and if I do like run instructions, it runs through all the instructions, so the whole pipeline is going to be finished, right? So right now I can't set that up until I start doing my steps, which will keep loading, new things into the pipeline. Um, but anyways, so we have up here run instructions goes to execute instructions. Um, cache is enabled, the current type of cache. It starts another thread again. Then we go to handle execution. Handle execution then updates the registers and the memory. So this is updating all the registers and initializing them. And we're updating the memory. Well, actually, what's happening is, sorry, execute instructions um, calls to simulator execute instructions. So this starts, and right now I just have a hard coded value of 20. This would just be kind of waiting for the whole pipeline to be like nothing to be in the pipeline and then it would finish. So right now I just have it hard coded. And so we say, okay, while cycles, whatever. Then we call to a pipeline step. If we go to the actual pipeline, we have the pipeline step, and this calls in reverse. I still don't know why you call this in reverse, to be honest. It has to do with something with like not overwriting values, but it works, so I don't question it. So we step through the pipeline backwards, and then after we're done one cycle, we then update every single register that sits between the pipeline with what was just written. So when we're going through, each stage is writing to the the write back register, right? We write to the write back dot next. So when we finish the cycle, we then write to the register using the next, so we're not overwriting anything. Um, so all of these, I'm not going to explain all of these, but you can see the fetch stage fetches from DRAM at whatever the program counter is, decodes that into what execute will then use to, I don't know, add something or branch or something, along those lines. Memory access will see, oh, are they doing a load? If they're doing a load, we're going to go to cache. If it's a miss, then we're going to go to DRAM, grab that. If it was, a load, then we're going to also load that into cache after we get the value from DRAM. Then we return that, and then we look at write back. So, um, yeah, um, that is about it that I wanted, and then I can show you actually the whole running this. So right now, so the easiest one that I can show is if I load this. So it's literally just an add register 2 and 3 to 1. I have all the registers from register, I believe 1 through 13 already preloaded with the value of just 2. So if I do run instructions, you can see register 2 and 3 had the value of 2, so register 1 has a value of 4 in it. So if we reset and do a different file, so this one has an add, a subtract, a load, store, load, store, load. So if I run this, we can see a couple things. We can see, obviously, we added 4 and 3 to 5. So right here, that worked. Subtract 6 and 7, 8. This should be 0 because those are 2. And then we load from R1, which is 0. We load that, which I'm not going to show that one, but if we do then store word, okay, so this is register 0, which is a hard-coded 0 plus 15, which is the offset, to register 5, okay? So if we go here, I have it so that starting from address 500 in memory is where all the data gets stored. So at 515, we should see right here, we stored from register 5, and register 5 was what we loaded 4 into. So yeah, so, and then also the cache, we have a cache line here and a cache line down here for what we were loading. So yeah, so what I'm going to work on now, going into the night, basically, is working on that step, is being able to step through instructions and displaying that pipeline. And the big thing is going to be, I don't know if my logic for handling delay on read and write is good. And also on that delay, we have to stall the pipeline at those stages. So like we can move forward, like fetch, right? If there's nothing, if write back is stalled, but we can't move past write back. So I'm gonna have to make sure that's fine. But and then branching, I haven't tested any branching, so those are the two things we're gonna have to work on. It's only 10:40. I think I could. I mean, my class is at 9. I think I can get to bed by midnight or 1 and get this done and submitted by submitted. I don't need to submit it. Just have to present it. So class is at 9. I could probably go to bed by 1 and get a good 7 hours of sleep. So, okay. Well, that is all I have for now. I'll let you know how the presentation goes in tomorrow's video. And then we can start working on other stuff finally. Yeah, I'll be doing linear algebra a lot after tomorrow. But as for coding, I don't know. I think we have freedom of choice. So, okay. I will see you tomorrow for day 124, I think. Okay, take care. Bye.